Okay, so quadratic functions is a big part of Algebra 1, like second semester Algebra 1. So you should have some ideas with this. We will learn new stuff in this chapter that you have never learned before. It's pretty exciting stuff. It's imaginary numbers. That's exciting, right?
We talked about the.
But anyway, here's what you need to write down. This is the standard form of a quadratic function, ax squared plus bx plus c. And I'll try to get a copy of the reference sheet that's for the ICEP 10 so we can see what they have on that if you're a 10th grader. Maybe I'll even let you use that reference sheet on a test if it gives you some formulas, but we'll see what they actually do. Whoa, that's not what I wanted to do. So the quadratic term is the squared term, right? So when we're doing slope-intercept stuff, when we're graphing linear lines, they don't have an x squared in it. So the x squared is what gives us the quadratic. The x to the first power is your linear term, and then no x is a constant term. And so those are the three terms that we have. Notice it says that a can't equal 0, because if a was 0, it would just be linear. And the graph is called a parabola, not parabola. Parabola, which we've talked about before already as well. The U-shaped graph, yes? So far so good, right? Today we're going to graph, and probably you're going to moan and groan a lot because it's not as easy as graphing slope-intercept form. It takes some time and some effort and picking some points, but that's just what you got to do, right? Not Desmos.
I mean, that's the, if I ever have to graph anything.
Well, when we take our quizzes and tests in here, Alex, you do not have Desmos, so you need to make sure that you're practicing without Desmos, right?
I don't know how to do this.
It's been broken for a long time. See what happens when you don't sit in the front row? So, we know the shape of this should be a U-shaped graph, so you need to pick some points until you get a U-shaped graph. When I taught Algebra 1, I usually said you should pick 5 points. But now, when I teach Algebra 2, I say you should just pick enough points until you get a U-shaped graph. If you don't get a U-shaped graph, then you have done something wrong because it should be a U-shaped graph, right? So I like to pick, I don't know if this is going to work, but I like to start by picking like -1, 0, and 1. Those seem like good points to pick, right? You can really pick whatever you want, and maybe as we go forward today, we'll find better ways to pick numbers. But what do I do? If I pick x's, what do I do to find the y's to go with them? You just gotta plug them in, and you can use a calculator. Be really careful when you're typing squared stuff in your calculator. I always say use parentheses or just do it in your head, but you need to be able to do this. So who needs a calculator? If you don't have a calculator, you should raise your hand. Oh my gosh, that's what it says.
Throw stuff. Whoa.
Here. Squall.
Ooh. Dang.
Okay, focus back, guys. Focus back. When you put -1, if you're typing this in your calculator, you should do parentheses -1, and I believe there's just a squared button, isn't there? It's not, you can use the caret button. But if you don't put parentheses around the negative number, it will give you the wrong answer, at least on my calculators. And then +3 times -1 minus 1. Like, you can really type it in all at once, but you have to be proficient in typing it in correctly, because the calculator can give you the wrong answer if you don't type it in the right way. But what is that? 1 minus 3 minus 1 is -3. Did you get that?
Yes.
If you plug 0 in there, I don't even need to type that one in my calculator, right? That one's just going to be 0 plus 0 minus 1. That's going to be -1. You got -3 for 0?
Oh, no.
Oh, that's -3. That's right.
Oh.
If we plug 1 in there, we would get 1 squared plus 3 times 1 minus 1, which is +3. Let's see what happens here.
Yeah, because the -1 is -3 and positive.
No, that doesn't make sense.
Yes. Right? It should have. That makes sense.
Did you get this? Oh look, why do you let me do such things?
No.
This is right, right? I graphed -1, +3, but it's -1, -3. Is that a U-shaped graph?
Not yet.
Not yet. It looks to me like this side's like going up. So that means I think we need to pick some points over here so we can see like if this side's going up, right? So I'm just going to pick -2 now. And I promise I'm going to give you a better way of doing this in a minute that you don't have to just randomly pick. But you can always just randomly pick. It just sometimes takes a while. 4 - 6 - 1. Oh, I got -3. So when I plugged in -2, I got -3. Is that right? Did you get that?
Oh. Yeah.
Right here? Did you get that? Sure or no? Or yes?
Yeah.
So let's pick -3. So that would be 9. Times -3 - 1. I got -1.
Hey, following the trend here.
Looks to me like it's this side's going up like this, right? This side's going up like this. But we didn't pick what's happening in between there, but I'm guessing that that's where that vertex is, that point is. Like if you really wanted to, we could pick -1.5, or I'm just gonna do this. Like make a little connector there. Not a straight line, but like that little U shape there.
It's a mini U and C.
What should happen every time is you should be able to get some points that are the same on both sides because a parabola is symmetric, right? And we're going to talk about that on the next slide here. There's this line that you can fold that parabola over and it should be the exact same on both sides.
Is that geometry stuff?
I mean, it is geometry, but it's also algebra. So that line that I was just talking about here, that is called the axis of symmetry because it's a line that makes the parabola symmetric. So whatever point you have on this side, it flips it over. It's like find one point, get one free. Like buy one, get one free, only it's with points. That point, the one point that is not symmetric is the vertex. That's like the turning point of the graph when you have that, all right? So here's our equation. The y-intercept is always what you get when you plug in 0 for x. So notice that the y-intercept every time will just be the c value. So that's like a free point on your graph. So that's a good one to know. The axis of symmetry and the vertex. And again, I want to check the I-Step 10 paper. The old I-Step or the old ECA, they gave you this formula. I don't know if the new one does or not. But the equation for this, coming from this equation, is the line x equals -b over 2a. So you need to make sure you write that down. And that is because the vertex also starts at that line. So you'll notice the x-coordinate of the vertex is that same formula, -b over 2a. And so when I graph these, instead of just randomly picking points like we did on the first problem, I always start with this -b over 2a because that gives me that turning point. And then I pick a point on either side of that, or maybe I use my y-intercept to graph that. So you can always just randomly pick, but if you use this stuff, you can do that a lot quicker, I think. Questions about this? Vague memories of this flooding back to you from Algebra 1 class?
Yeah. Let's figure it out. I said this.
All right. So this is what you're going to do on your homework. It says, find the y-intercept, the equation for the axis of symmetry, and the vertex. Then make a table of values, I'm going to say if needed, to graph this equation. And we're also going to talk about our good old friend domain and range. So first of all, what do you notice about this equation compared to the other one that we did already? It's switched around from the way that we know it, so you have to make sure that you know ax squared plus bx plus c. Those are where those numbers come from, of what's in front of x squared, what's in front of x, what's by itself. If you don't have it in that order, just make sure you know which one's which. Or, like on this one, I could just switch it around and I could say that's x squared minus 6x plus 3. So I can flip the order. Which means, in this problem, what is A? A is the number in front of x squared. So A, B, and C are always numbers. They're never x's. So the number in front of x squared here is 1. And B is negative 6, because the sign comes with it. And C is... Questions on that part?
Divide by?
Not dividing anything. I was just underlining it. So, find the equation of the axis of symmetry and the vertex. We'll do that first. So, the axis of symmetry is x equals negative b over 2a. So, it's important that you know what a and b are. So, b is already negative 6. So, what's going to happen when I plug in negative 6 into negative b? Yeah, and I'll just show that. But you would have a negative of negative 6 over 2 times a, which is 1. So all I'm doing is plugging in the a and b from the problem into this equation, and I get 6 over 2, or that's just 3. Right? So you got to make sure you simplify that correctly. So I'm just going to say x equals 3. That's the line that's going to cut my parabola in half. The other thing that's really good about this is that gives us part of the vertex. That gives us the first coordinate of the vertex is also negative b over 2a. How could I find the y value that goes with that? Chandler.
What?
Quit talking.
Okay.
So if the vertex x coordinate is 3, how do I find the y that goes with it? You just plug 3 in, right? If x is 3, to find the y value, we're just going to plug it in just like we made our xy chart before. So all I'm going to do is plug 3 in to get this value. So I'm going to go up here, right here, and I'm going to do f of 3, and that's going to give me 3 squared minus 6 times 3 plus 3, or you can use your calculator. Negative 9 plus 3 is negative 6. So, the first one we just randomly picked and kept picking until we got the graph. On this one, if we start with our vertex and our axis of symmetry, and I kind of skipped over that y-intercept, but let me show you how we can do this without really having to make a table of values. And I think if you flip your page over, I know it kind of stinks because it's flipped over, but I put a graph for you on the next page. So I'm going to start with my axis of symmetry. So x equals 3 on the x-axis. Over here at 3, I'm just going to make a dotted line because it's just this imaginary line that you can fold the graph over. Okay? If you don't even want to make that line, you don't have to. But I'm trying to be like the picture is. And then I'm going to graph my vertex. So that's my point. I know on that line, if I go to 3, negative 6, that is that turning point of the parabola. And now here's where we could make a table of values. But here's where I think, as long as your vertex is not also the y-intercept, you can use your y-intercept and not have to do any more work than the work that we just did. The y-intercept is what you get when you plug in 0 for x. I can even make a little xy chart here if you want. If I plug in 0 for x here, what do I get as my y-intercept? 3. Or the y-intercept is always the c value. It's always the one without an x because the other ones go to 0. Which means I could go over here at 0, 1, 2, 3, and I get another point on that graph. If there's a point right here, do I know where there's another point on my graph? Because it flips over, right? So I can go, if this is 3 away, I can go 3 on this side.
Which looks like a absolute value graph.
Well, that's where you have to know it's a U-shaped graph, or maybe you should pick another point if you think, right? So here's what you shouldn't do. we shouldn't just connect this and make it a straight line because we know it's not a straight line. So if I was doing this, I know it's a U-shaped graph, so I make sure that I come out and I make it a U-shaped graph. If you think that you might make it a V-shaped graph, you better pick another point, right? So that's where you could pick another point next to your axis of symmetry and plug it in, and you'll see that it's going up at a not a V-shaped graph. All right, so this is the way that I think is the best way to graph, because you really kind of need that vertex point. And if you can use the y-intercept. If you couldn't use the y-intercept, like maybe the y-intercept's like 20, you don't want to use that, that's where you would just pick another point. Like, and I would always pick the point right next to my axis. So like if I was doing this, I would have picked 2 as my point and plugged it in and used that to do the rest of it there. Questions about that? Do you have any memories of that?
What is AP calculus?
What is what?
AP calculus.
People that get credit on the AP test.
So it's really that hard that a lot of people don't get credit?
Not a lot of people take calculus, right? So I only have 6 people in calculus this year. That kind of weeds people out, right? Because we take pre-calculus, and then people are like I have like 30-some kids in pre-calculus, and then I always have like maybe 10 kids in calculus.
What else do they take?
Mrs. Bai teaches quantitative this year. We might teach a stats class at some point, but some people just don't take a math class.
Yeah, 'cause I know Nick Tyson. 2 years in math.
Okay, back to this stuff. So the other thing that we need to know, besides how to graph, is we need to talk about maximums and minimums. So, again, I bet you remember this, but in your quadratic, if A is positive, then you remember that your graph always opens up, right? And it's easy to remember, because if it's positive, it's happy, right? Positive means happy. So it looks like a smiley face. Ah. And if it opens up, then it's going to have a minimum value. And by that, I mean that it has a low point on the graph. Ooh, we need to go back and do domain and range. Why'd you let me forget?
Sorry.
It was Alex's fault, really.
What?
If it opens down, that means that the x squared term is going to be negative, and that's because it's a reflection. But if x squared is negative, then that parabola is going to open down, and it's going to look sad, like a frowny face. Negative, sad, right? It's easy to remember. And it's going to have a maximum value, meaning that there's going to be a point that it never gets higher than. So we talked a lot about domain and range when we talked about absolute value graphs and those step functions and all that stuff, because they had crazy domains and ranges. And then when we talk about linear functions, we don't really ever talk about domain and range because it's always all real numbers. X can be anything. Y can be anything. But when we go back to this graph, we want to talk about the domain and the range again. Domain is what can X be. So think about this graph. And I forget what it was already. X squared minus 6x plus 3.
It could be negative.
Can you plug anything you want in for X into this problem?
Yep.
And if this graph kept going on forever, eventually, would every X value over here have a point up there on that graph that it goes to, and every X value this way? It's a nice smooth curve, it's continuous, means that the domain, just like we said before, pretty good guess that domain is all real numbers, and I like to write it in interval notation, negative infinity to infinity.
So, what's the point of graphic equations? Why? Why couldn't you just solve it out algebraically? Like, why did they decide, let's put this on a grid?
Well, there's certain things that we talk about the path of, and like that's just what the graph of it is, right? Like, people that are letting off fireworks, right? If you shoot something up like a firework, it's going to make a parabolic curve, and so people that are putting on fireworks shows have to think about, like, where do I need to let these fireworks off so that it's safe, and so that people can see them, but it's not too high or too low, and that's using a graph, right? Like, mapping out what's happening is
but you could
a
also
graph
put
of
that
it.
into an algebraic equation, couldn't you?
Yeah, don't do
Which would be more accurate. Like,
You would be more accurate.
If you
Maybe
could-
like that.
but just seeing it, right? And we have Desmos, and we have ways of graphing it with technology, which is why we want to do that also. And that's going to be accurate as well, right? But sometimes it's nice just to get a sketch and see what's happening. And we'll talk about projectile motion in this chapter of a parabola opening down. If you launch a rocket or something, like the shape of that is going to be in a parabolic thing. I saw this project about Angry Birds, and it said like teaching parabolas using Angry Birds, because when you play Angry Birds, those birds are flying in a parabolic shape. So, the range is the y value, and another reason it's nice to look at graphs is sometimes if you have the graph, it's a lot easier to see the range than if you didn't have the graph. The range is the y values, and since this graph is opening up, since it has a minimum value, do you agree that not all the y values are being used? So when it opens up, you're always going to have this low point on your graph of like the lowest the range can ever be. So remember, range is the y, so you just go over here and you tell me what is the lowest y value that we ever get on this. That's the x value, right? But we want the y value that goes with that, which is -6, and then it goes up forever to infinity. Could you figure out what that y value was without having a graph?
Mm-hmm.
Like what part of the graph is that low point going to be on? The minimum or the maximum? What's this point also called? The vertex, which means if you know the vertex, it's always just going to be the y coordinate of that vertex is going to be your maximum or your minimum, all right, which is also going to be your range. So the other part that I'm making you do today on your homework, I'm making you graph. I'm also making you answer questions like this that say determine whether the function has a maximum or a minimum, and then find the value and state the domain and range. You shouldn't have to graph these to do these problems, because the domain and the range have to do with the vertex as well. The max and the min have to do with the vertex. So if we can just find that vertex, we don't have to graph these. So I didn't give you graphs with those. So step 1, you have to figure out whether this opens up or down. So this is what tells me. Because this is negative, I know that it's going to open down like this. So if it opens down, does it have a maximum or a minimum?
Maximum.
Because it has a high point, right? So we can say that this is going to have a maximum. Determine whether the function has a max or a min. Maximum. Then find that value. Now that's the part you have to do some work on. The value is the y coordinate of the vertex. All we know about the vertex is that it's -b/2a, and then you got to find the y value by plugging that in, right? I don't have really a good way to write that without it being scary ugly. But you have to find this value for your max and your min, but you got to start with the x value. All right, so I'm going to start by doing -b/2a. So again, this is my a, this is my b, this is my c.
Oh, I see.
So I'm going to say -2, because b is 2, over 2 times a. What is a in this problem? -1. So I get -2 over -2, which is +1. Again, use 1, plug your numbers in correctly. 2, make sure you simplify correctly. And sometimes this might be a fraction, and that's okay because you have a calculator that you can use, okay? But 1 is not my answer, right? That's the x coordinate. I know that the x coordinate is 1. So to find my max or min, I have to plug 1 back into that problem every time. So now let's talk about typing this in, all right? So I'm going to say over here, f of 1 equals -1 squared plus 2 times 1 plus 3. Okay, everyone pay attention for a minute. Earlier, when I said we plugged -2 into the x squared, right? When it was x squared, I said you had to do parentheses -2 squared because we were plugging that in there, right? This is different. When the negative is in front of the x squared, that's like saying -1 times x squared. Order of operations says we do exponents before we multiply. So when you type this in your calculator, you don't put the negative in the parentheses. Like this is saying we're going to plug 1 in here, so we're going to get 1 squared, and then we're going to multiply by a negative. So just be really careful because it's easy to get the wrong answer there. Or if it helps you, rewrite it as -1 times x squared. So you can do -1 times 1 squared, and then you won't get it wrong. But that messes people up all the time. We're going to see that a lot whenever you have a negative x squared. So when I type this in, I'm actually going to get -1 plus 2 plus 3. 5 minus 1 is 4. So the maximum value of this function is 4.
1, 2, 3, 4.
Questions about that? The other thing we want to talk about here is domain and range. What's the domain of every parabola always going to be?
All real numbers.
All real numbers. You should not miss your domain and range because every single parabola will have a domain from -infinity to infinity. Will the range ever be -infinity to infinity? Never, because there is a maximum or minimum. So on this one, we know that it opens down now. So we know the high point here is 4. So my question is, when we write this in the range, is the first number going to be 4 or is the last number going to be 4? Because it's a high point. So that means that this is going to be 4 and it's going to go down, right? It's going to go down forever. So that's going to be -infinity up to 4. If it opens up like the one we just graphed, then the minimum is the first number and it goes up to infinity. And so your range will either go down to -infinity or go up to +infinity.
Can't really say all of the same angles. Okay? Well, is that not called a parabola? Sideways.
It's called a parabola, but we are not doing those until pre-calculus. So every parabola that we will ever do in this class will be that. But you're right. In pre-calculus, we talk about parabolas that can open left and right, and you're right. Is that it? Oh, look, I had another one here. Okay. All right, you try this one. So just like the last one that we did, think about, don't say it out loud. Does it open up or down? Draw the picture if it helps. Is it going to have a max or min? And then you have to find that vertex. That's the part that you have to do. -b over 2a. Is it about this? No. I'm not answering.
If I get it done, can we
No.
answer it after class?
It's nothing. It's just a made-up holiday. It was right in Halloween.
Okay.
Doing your range. Supposed to know what's about. So you start with your -b over 2a. Remember, it's the y value. So if that's your -b over 2a, that's not your max or min. That's the x value.
Oh,
Right.
Oh.
Because you didn't write any of it down.
I did it.
You didn't. I just saw your paper. The point of notes is that you have something to look at to try a problem by yourself. That is why we take notes. So since this one, x squared is positive, that means that one's going to open up. And I always think it's helpful to draw a picture because when I look at this, I know that that one is going to have a minimum instead of a maximum. I could even go ahead and answer that I know the domain is -infinity to infinity. And I don't know the minimum value yet, but I know that it's going to go up to infinity, and I just got to find that number, that minimum value. And so those are the things that are going to be the same every time there's a minimum. And if it was a maximum, you would always know that it's going to be negative infinity to some number. And so then this is the part that you have to do. The negative b, so negative 4 over 2 times a, which does give me negative 2. But that is not my minimum value, right? That's the x-coordinate of my vertex. And this is your max or minimum, right? The y value. So you have to make sure you plug that back in correctly, either with or without a calculator. And on this one, we would get 4 minus 8 minus 1, or negative 5. Should you get negative 5?
Yeah.
So the minimum is negative 5, and then that's what goes in my range value there. And that's really all we're doing today. There's a couple other problems on there that I'm sure we'll talk about tomorrow. But this is like day 1 quadratics. We are going to solve quadratics. And Alex is right by saying that graphing is really not the best method if we're doing it by hand. Which is why very quickly this week we will get into solving by factoring, by using completing the square, and by the quadratic formula.
Can you give me a quick example of factoring out?
Like FOIL, like undoing FOIL.
Oh, FOIL.
Alright. Good.
Okay. So what's the reason why it's going?
Okay, so I want you to do
I'd be scared I'd do that.
Hollywood.
1. Through 4, 7, 8, 10, 11. So really, yeah, most of them.
So those are the ones we don't do.
So you're just not doing 5, 6, and 9. Like I don't think we need to do 6 of the max min ones. So I just cut that down. I just was trying to pick out like a variety.
5, 6, and 9.
5, 6, and 9 you're not doing, but you're going to do the rest of these. You should have plenty of room on this. The back is blank if you need more space, but make sure you do the whole axis symmetry vertex thing on the graphs here. All right. And you do need to put my calculators back before you leave, but the good news is you have a calculator on your computer, right?
Yeah.
Again, I need to see work with those graphs because I'm aware that Desmos is out there. Tomorrow you will take a homework quiz and you have to graph one by hand. So I cannot stress enough how much you should not just be cheating your way to get 5 homework points and then missing test and quiz points.
That's much.
Okay?
We're just using our reason.
It's cheating when I say don't do it.
Oh,
I
okay.
didn't say don't do it.
What's using your resources is you graphing it by hand and then you checking it on Desmos, so if you know you're right or wrong, that's what you should do. Instead of just going straight to Desmos and then being like, oh yeah, I know how to do that, and then failing a quiz.
Yes.